So hello, this is Jeffrey. So we are doing evaluating composite functions. So this is the first unit on Khan Academy. So we're gonna go along with this unit. So the first thing you noticed about composing functions,
So we have three different function definitions here. This is f of x in blue. Here,
you will see that is one after another, right? So these are actually three functions right here, okay? So the first one is this, and the second one is being described by a table, and the third one is drawn in the picture, okay? So when you dotted these dots on the table into a graph, then it can form another graph. We don't know what that is for now. You can try it yourself, but that's beside the point, right? So what we are trying to do, okay, so here, um, the instructor was giving us this example. If g of x, I'm noticing the color, right, is green, so it's going to be 2. So when x is 2, right, this should be g of t. Even though you cannot see it, this should be g of t, right? So when your t is 2, that is you find a 2, your g of t, which is this table's y value, right? It corresponds to what? -3. Okay, but we have to test if there's any other 2. There's no other 2, so that'll be -3, right? Which is ideal. We don't want two answers. Okay, so it's -3. Then that jumps out, right, from inside to the outside, and that jumps out to f of x, right? But our x will be what? Which is g of t, which is y of this table, is -3, right? That becomes the f of x, the x of f of x, which is -3, right? -3, you plug it into here, which is 9, and -1 is 8, right? So supposedly this will be 8, okay? So let's see if it gives us another example here with regards to h of x, right? Okay, so now we have f of x inside of a g of x, inside of a h of x, and I'm assuming h of x is the graph in the beginning, the triangle graph, okay? So this is our problem right here, f of x 2, so we find the 2, remember the square, right? The square, so you jump into 2 is 4, and then -1 is 3. But then the next one will be what? G of x, right? The next one will be g of x. We got 3 from here, so we find the table, the 3, which is our new x, which is t. So it's going to be 3, and then that corresponds to just one answer, which is 4. And then you know the answer is going to be 4, but that will be our new x for h of x, right? So h of x will be this graph right here. So we got 4, so we find the 4, and that seems to be corresponds to our y in this graph, which is h of x, the -1, right? So you just plug in this value here. This 4 corresponds to -1. So supposedly this will be -1, right? -1, okay? So that's our introduction to composing functions. Okay, so here are some word problems. Don't worry too much about it because you can just use the same method, plug in and plug out, right? And then 2 acres, that gives you the new x, which is 13,500 kg, and plug into the money function, which is our x, in the money function, and that gives you the 12,100, right? Okay, so that's the problem here. Okay, so using the function presented in the example, how much can Cam expect to earn if he sells all the corn produced on 1.5 acres? Okay, 1.5 acres. So you first use the 1.5 acres. See the A right here? So you plug it in there and find your crop value, right? How much does your crop weigh, I suppose? So 7,500 times 1.5 acres. That will give us what? 7,500 times 1.5. That's 11,250 minus the 1,500 at the end. That gives us 9750, right? That's our crop value, and you plug into the money value, which is here. So then you have to times 0.9, right? Immediately you have to times, because you plug in here, C, right? You have to times 0.9, which gives us, oh, sorry, I used the minus, so plus it back, 0.9. Okay, let's redo this. So 9750, which was our answer, times 0.9 equals to that number and minus 50, right? So our total value that we can transfer to is 80, A725. Okay, $8,725. Check. Okay, good. Okay, so I'm sure you're gonna do well on this too. So it's pretty straightforward. Just starting from the very inside of every composing function, and then you work your way out, right? Okay, composing functions, continue. Let's do another one. Okay, so the only thing that is introduced here, let's do number 2 for now. So n of x first, right? So n of x is what? We don't have that, but we put it into m of x, right? So you put the whole thing in, right? So the whole thing will look like, because there's no value like this one. I'm glad we're working on this, right? This is new. Okay, so you put the whole thing in. This is your m of mx, right? But your x is no longer x. Your x is the whole function of n of x. So your x will become this, right? Okay, so this will be put into our older x, which is this whole block right here. Algebra is always like replacing, right? Replacing your old unknown numbers, unknown variable. So your new variable will be looking like this. The whole thing will be replaced, right? But the constants stay constant. The constants stay constant. They'll remain the same. So the whole thing will be 3x plus 12 minus 2. Okay, so it's 3x plus 10. Okay, let's try that. 3x plus, okay, I'm using Chinese. 3x plus 10. Check. Okay, good. So the only new thing that is introduced in this section is that there's a notation, okay? A formal definition of composite function, right? F composed with G f composed with g, it's inside of, actually g is inside of f, so it's composed of, right? Composed with this, right? F is composed with g, right? So f will be on the outside and g will be in the inside, right? Okay, so that will be our formal notation, which is a dot, right? Or you can write it like this, just what we are used to do. But now you can do that, like you take the two functions notation out, f of g of x, right? Pretty easy. Okay, so let's look at a problem here. So g of f of 3, okay? So f of 3 first, right? So you plug in the 3, 9 minus 5 is going to be 4. So that's going to be 4, 8 minus 8 will be negative 5, right? Check. Good. Okay, so we're going to just do one question. We don't have, oh, challenge problem. Okay, let's do this. So this looks like a cosine for me, right? This looks like a cosine for me. Later on, we can look at the trigonometry. You know, there's sine, there's cosine, and it looks like a cosine to me. And this is like a straight line function, so there's no worry about that. But what's the point here? It is just wanting us to do the composite function, which is g of x, g of 8 first, right? G of 8 first. Okay, g of 8. G of x is right here, so it's the greener one. I will say this is the bluish one. This would be the greener one. So this is the g. You plug in the 8. So find the 8 corresponds to what? 2, right? So now you get the value 2, and you plug into f of x, which is right here, the blue straight line function here. Okay, 2 is kind of tricky because, okay, so this is negative 4, 5, so this is supposed to be 3, right? So this corresponds to negative 3, I would say, which is right here. Okay, check. Okay, correct. Okay, so right now we're going to go for this one right here,
Come
which
out to
is
be
another
exactly. So h of g of negative 6. The way it's written might look a little strange to you.
composite function. Composite, doesn't matter. Okay, x squared plus 5x minus 3, and this is another one. And negative 6, sorry. So you do the g first, okay? So plug in the g, so you find out this is 36 minus the 30, so you're left with 6 minus the 3, which is 3. And you plug in the h, so this is 2, 2 to the, you do uh, you do the square first. So 2 square is 4, 3 is 12, right? 12 minus 5 is 7, right? Okay, 7 supposed to be 7 right here. Okay, so we got it. And move on to another one. Okay, tables.
I want to go within the
This is
parentheses.
a new thing, but it's more or less the same, okay? So let's get our question here. Our question is g of f of g of 0, right? That's how you say it. F of g of 0. So you do the g of 0 first. G of 0 you found out corresponds to 5. No other answers, right? No other zeros corresponds to another answer, so that will be 5. That's fine. Okay, plug it into our f. We find our, that's our x, is not our y, right? We haven't found the y for f of x, so we just do the just try to find 5 over here, which is here, and that corresponds to 11. So our answer will be 11. Okay. um, 11, okay? Okay, so what if it is the opposite? Now it's g of f of 0. Now we have to find this first, right? Now we have to do f of 0 first, which is here. F of 0 corresponds to 1. Okay, so now you plug into 1 in our g, right? So you found out it's going to be 8. Okay, so that is 8. Okay, good. Now move on to the another table, I believe. Okay, graph. So you see the patterns, right? You have your ordinary function, and you have to do the when you talk about functions, you got to do the graph, you got to do the tables, and tables gonna be forming graphs, right? Okay,
We have the function f.
f negative 5, f of negative 5 is here, which doesn't really isn't anything actually, because supposedly it can be on the 5, negative 5, but it's not there. Oh, it's gonna be here. It's gonna be negative 5. It's gonna be here. So I'll say it's gonna be negative 2, okay? Right? When you find, so same thing here, where you try to find negative 5, that corresponds to where on the graph, on this functions, right? The graph of this function is right here, is the blue line, blue quadratic function here. That corresponds to your value on y, which is negative 2. That gives us the new x for g of x, right? So g of x is right here, is the purple one. And we got the negative 2, so you find the negative 2, that corresponds to 1, okay? So the answer should be 1. Okay. Yep, it's gonna be 1, okay? So you get the picture here. Finding composite functions. Okay.
Function composition. So for
Okay, so here we have two functions. So by this time you're gonna know you're just changing it, okay? Changing the x to the new complex variable, which is what you have inside, right? So here you have f of x, but your x is no longer x. It's gonna be complex. It's gonna be replaced by the whole g of x, right? So you have a complex, of course you're gonna have this as your f of x, but the whole x, as I said before, has been replaced by the complex one, which is 1 plus x, and the whole thing will be square. Think of it as a big square, like a square you can replace by any numbers you want, but in this case it's gonna be another rational expression. And coupled by the square that you have, the format you had before, which is square, right? Minus the 1, okay? I don't know if you should simplify this. It, this is not simplifying it, so I guess you don't have to unless the teacher tells you to. Okay, so the other way around, just you can play around with it. We're not gonna go right? The original x has been replaced by the f of x. That is the opposite way to do it, okay? Okay, advanced. What's advanced about it is you're gonna have 3 probably. Okay, so I guess there's nothing advanced about it for now. What was our original question. So g of 8, so you plug in the 8, okay? But oh, here, it's complex. It just increased the complexity. There's nothing too advanced, right? I'm sure you can handle this. You just find the answer here, right? So g of 8, you plug in the 8, but this will become h of t, okay? H of t, which is where you get your answer here, right? So you plug in the 8 here is 24. So let's just do this. Let's just don't be lazy. Let's just do this. Negative 2t, that it gives us 8. So negative 16 minus 2. And negative t, what we said was 24. Okay, so that's 42, right? Negative 42, that has to go to h of x. Okay, so let's see if our answer is right. 24, right? That's correct. Okay, so our whole thing is negative 42. Okay, so now where are we right now? G of x, we got it. It's negative 42. Now the outside is h of x, so times 3, right? So that gives us 6, 12, negative 126,
42 is the same thing as g of 8. So this is h. If you just keep track of what's our input,
negative 126, right? Okay, so there's nothing involved. This f of n just to confuse you, right? We haven't even touched on it. Okay, so that's it. Good luck on your test and see you on the next episode. Thank you for watching.